Do your kids ever just follow the math steps without truly getting it? Or maybe they understand the concept, but they struggle with actually performing the calculations. If you've ever wished you had a roadmap to help your homeschooler not just do the math, but truly understand and master it, then you are in the right place. We are going beyond the why of conceptual versus procedural math to the how, offering concrete, actionable strategies and real-world examples you can use starting today to build that essential bridge between conceptual understanding and procedural fluency. Hey, homeschool mom, I'm Erica Sagert on the Intentional Homeschooler podcast with more actionable steps and encouragement for your homeschooling journey so you can confidently and intentionally homeschool your children without sacrificing your sanity. Grab a pen and paper, your favorite cup of brew, and let's get started. Last week, we dove deep into the crucial distinction between conceptual and procedural math. We looked at the why versus knowing the how. We talked about the profound impact this difference has on our children's connection with numbers. If you missed that episode, I highly recommend going back to listen since it lays a fantastic foundation for what we're about to explore today. Today, we're moving from theory to tangible action. We're going to get down to the nitty-gritty of how we can actually implement these ideas in our homeschool math lessons. How do we, as parents and educators, foster both that deep conceptual understanding and the necessary procedural fluency in our children? Let's dive deep into some practical, real-world examples. Example number 1, teaching addition with regrouping or carrying over. So let's start with something that we are all very familiar with, that addition with regrouping or carrying over. So let's go over the procedural approach first. So a purely procedural approach to 27 plus 15 might involve teaching, number 1, line up the numbers, add the ones column, 7 plus 5 is 12, put down the 2, then carry over the 1, then add the tens column, 1 plus 2 plus 1 is 4, so the answer is 42. While this is correct, it often leaves children just following steps without truly understanding why they are carrying over that 1. They might not even know what that 1 truly means. Whereas a conceptual approach, which should be taught before the procedure, before we even introduce that carrying over rule, let's build the concept. So manipulatives are key here. So you can use base 10 blocks, bundles of 10 sticks, or even pennies and dimes. So lay out 2 tens and 7 ones for 27. Then lay out 1 10 and 5 ones for the 15. Now, combine the ones. You have 7 ones and 5 ones. Count them. 7 plus 5 is 12 ones. Hopefully, at this point, there will be an aha moment. So you can ask, can we make a group of 10 out of these 12 ones? Yes, bundle 10 of those ones together to form a new group of 10. Now you have 2 ones left over and you've created one new group of 10. Connecting to the tens place. So then you place that new group of 10 with your other tens. Now count your total tens. 2 original tens and then 1 original 10 and 1 new 10. So 4 tens. And you have 2 ones left. Okay, so the translation here, when we added 7 and 5, we got 12. That's 1 10 and 2 ones. The 2 ones stay in the ones place, and the new 10 goes over to join the other tens in the tens place. That's why we carry over the 1. So now after this hands-on exploration and understanding, then you introduce the standard algorithm. The carrying over now makes perfect sense, rooted in the idea of grouping tens, not just an arbitrary rule. Practice with various problems, but always encourage them to visualize or even briefly use their manipulatives if they get stuck. All right, example number 2, understanding fractions. So fractions can be a real stumbling block if taught purely procedurally. To add fractions, find a common denominator. Okay, but why? So the conceptual approach here, here's a real life example. So imagine you're sharing a pizza. So use a real pizza or draw circles and divide them into equal parts. Show one pizza cut into 4 slices or fourths and another identical pizza cut into 8 slices or eighths. Ask, if I have 1/2 of a pizza and you have 2/4 of a pizza, do we have the same amount? Visually demonstrate that yes, those amounts are equal. This builds the concept of equivalent fractions. Then you can discover the why of common denominators. So present a problem like 1/2 plus 1/4. Ask, can we add these directly? Can we add apples and oranges? No. So how can we make them the same thing? Guide your students to see that if we cut the 1/2 pizza into smaller pieces, we can make it into fourths. Draw a line across the 1/2 to turn it into 2/4. Now you have 2/4 plus 1/4. Now can we add them? Yes. How many fourths do we have in total? 3/4. This shows them that the common denominator isn't just a rule. It's about breaking down the parts into the same size so they can be accurately combined. Now, for integrating the procedural practice. So once they grasp the why of equivalent fractions and common denominators through visual models and real-world examples, then introduce the procedure for finding the least common multiple or multiplying the numerator and denominator. They'll have a much stronger foundation for applying the rules. Example number 3, long division. Long division is often presented as a multi-step algorithm that feels intimidating. So here's the procedural approach, isolated steps. Okay, divide, multiply, subtract, bring down, repeat. This can feel like a very mechanical process where one misstep derails the whole thing. And there's little understanding of what's actually happening to the numbers. So let's talk a little bit about the conceptual approach to this, or understanding the grouping. So let's say we're dividing 145 divided by 5. So think in terms of sharing or regrouping. So we have 145 cookies, and we want to share them equally among 5 friends. How many does each friend get? So visualize the chunks. So start with the hundreds place. So can we give each friend 100 cookies if we only have 100 cookie package? Nope, not enough. So we break it down. So you move the tens. Okay, we have 14 tens or 140 cookies. Can we give each friend 10 cookies? Yes. How many tens can each friend get? Let's try 2 tens. So 2 times 5 is 10. That uses up 10 tens. We have 4 tens left. So now you connect to the algorithm. So this directly relates to dividing the first part of the number. The 2 in the tens place of the quotient represents those 2 tens for each friend. Now we have 4 tens and 5 ones, or 45 cookies. How many individual cookies can each friend get from these 45? Guide them to 9 times 5 is 45. Now connecting to the algorithm. The 9 in the ones place of the quotient represents those 9 cookies. Then you want to emphasize remainders. If there's a remainder, discuss what that means in the context of the problem. There are X cookies left over after everyone got an equal share. All right, once they understand that long division is essentially a systematic way of breaking a larger number into equal groups and distributing them, the steps of the algorithm become a logical shorthand for that process. They can see why they multiply, subtract, and bring down. It's about determining how much was distributed, how much is left, and bringing the next digit down to combine with the remainder for the next distribution. All right, now I would like to go over some general strategies for math at home. So beyond these specific examples, I want to give you some strategies to foster both conceptual understanding and procedural fluency in your homeschool journey. So first, don't be afraid to slow down. So resist the urge to rush through topics just to get it done. Spending an extra day or two on a concept, exploring it with manipulatives and real-world scenarios will pay dividends in the long run. A strong foundation prevents future struggles. All right, the second thing, general strategy, is to ask open-ended questions. Instead of what's the answer, ask, how did you get that answer? Why does that work? Can you explain your thinking to me? Is there another way you could solve this? What would happen if we changed this number? Then encourage error analysis and embrace mistakes. So when a child gets an answer wrong, don't just correct it. Ask them to explain their process. Often, a procedural error stems from a conceptual misunderstanding. So use it as a teaching moment to re-explore the why. Celebrate mistakes as opportunities for deeper learning. When you go over these problems and you analyze why it's wrong, that is where you're going to have a lot of aha moments. All right, next, consider game-based learning. So there's many math games, both board games and digital. These are fantastic for reinforcing both concepts and procedures in a low-pressure, engaging way. Look for games that require strategic thinking and number manipulation. All right, next, use story problems and real-life scenarios as your starting point. So instead of presenting bare equations, just random numbers in an equation, start with a real-world problem that requires math to solve. This automatically engages the why and makes the math relevant. All right, my last general strategy for homeschool families, use varied practice, not just rote memory. So of course, memorization has its place, and they're going to need to have their math facts memorized. But once a concept is understood, vary the types of problems that they encounter. So present it in different formats with different numbers and in different contexts. This helps solidify both conceptual understanding and procedural flexibility. Ultimately here, the goal isn't to choose one over the other. You don't choose conceptual over procedural, but to create a harmonious blend of conceptual understanding and procedural fluency. We want our children to not only know how to solve math problems, but also to understand why the methods work. This deeper understanding will empower them to tackle more complex problems, think critically, and develop a genuine appreciation for the beauty and logic of mathematics. Let's move beyond simply teaching steps and focus on unlocking the why behind the numbers for our children. So, you want to homeschool your children, but you just don't know where to start. Or perhaps you're a seasoned homeschooler looking for some fresh perspectives. I've got something just for you. I'm hosting a special free info session where I will tackle the top 3 questions I hear from homeschoolers. How will homeschooling fit into my life? How do I know if I'm doing it right? And will my child be isolated? I'll dive deep into these concerns and offer practical strategies and insights. Plus, I'll have a dedicated Q&A session where you can get your specific questions answered. So, if you're ready to take the next step in your homeschooling journey, join me for my next free info session. You can find the sign up in the show notes. Don't miss out. I can't wait to see you there. You can also follow me on Facebook, Instagram, and YouTube, as well as right here, where a brand new episode will drop every other Thursday. Until next time, you've got this, Mom.